enough on stretch reflex. Of course, you'll read this up on your own as well. Now we discuss the contractions of the voluntary section. Welcome back. We've done this, the hybrid car analogy. We've discussed how alpha motor and gamma motor together work. But just to jog your memory, remember this diagram which I just showed you? Yes, in the beginning of the lecture. Is there any mention of the gamma motor? Nope. Because this is your typical stretch reflex contraction brought on by the stretching of a muscle. Again, this should be very clear now because we just discussed it in the FaceTime discussion. Okay? So it's important that when muscles get stretched, they get contracted and then they stop this business. So one single stretch should be followed by one simple contraction in a reflex world. Okay? Is this clear? The next slide would have been very controversial if we hadn't had the FaceTime this morning. Shall we proceed? Yes, Noor. It is stretch-induced stretch reflex. That's right. Never say it to an examiner. He may get confused. Okay. To the controversial slide. Not too controversial for you guys though. Hopefully. Voila. So do gamma motor neurons have anything to do with stretch reflex? Is the elephant in the room, isn't it? Yes and no. You know the yes and you know the no. I'll say it out anyway. Yes, because they do set the muscle sensitivity. And this sensitivity, remember the rubber band thing that I did? So by setting the sensitivity, they sort of adjust or they set the stretch reflexes intensity of the response. So if they are more taut and now you stretch them, they will respond more than if the gamma efferent is not very angry and it's just basal level and now you stretch it, the response will be more mellow. Welcome back. Do you follow this bit here? This discussion? You should, because we have been discussing this. This business of muscle spindle sensitivity set up by the gamma motor neuron. You should be able to understand this now. If you're not, then you have a backlog issue and you need to clear some concepts previously discussed. Okay? So with this, we move on to the no. Why is it? Well, we've discussed the yes. We'll now discuss the no, because it doesn't have any role to play in the reflex muscle contractions brought on by the muscle stretch. We just discussed it. Capish? Guys, where are you? Hello, is anybody in the house? The examiner may never ask you this. That's why I've mentioned it, that these are deep concepts. The examiner will probably ask you the function of muscle spindle, which I'll show you in a slide anyway. You just say that. They will ask you stretch reflex, what does it do? What is the role of gamma efferent? You know, the mundane type of questions. However, it becomes interesting if the examiner goes into, if the examiner likes CNS physiology and he likes you at that moment, or she likes you, then he may throw at you a clinical disorder or a clinical scenario which involves this business. Now that will be most interesting and a place where you can show off your credentials. Okay? But the basic stuff is basic. For my students, this should be basic. Yes, That's right, Abdullah. That's right. Okay, we move on. Clear this up. A bit about anatomy. I can't get away from it. I was thinking where to place this information. To be honest, this slide should naturally go to this slide, but then you would say, hey, welcome back. Noor, the jury is out there on that one. Anyway, so the origins of the gamma motor, very quickly, you will study this, should study this in anatomy. By the way, 30% of the total motor output is gamma. So gamma motor is not your, is not insignificant. So out of 100, it's actually 30, which is saying a lot in biology. Okay. Uh, the main area is this guy here, this region here, in the brainstem. So remember brainstem when you are thinking about gamma motor efferents. This area is found to be the most important in stimulating your gamma motor efferent neuron in the spinal cord. Stuff comes out of this area a lot. Okay, it has been found. Abdullah, insan ban jao. Okay. So, bulboreticular facilitatory region in the brainstem is the main instigator behind gamma motor functioning. Okay, and further, you will find these three we will be discussing later on: cerebellum, basal ganglia, and cerebral cortex. These also affect gamma motor, but also but even they are at the behest of bulboreticular area again. So remember bulboreticular facilitatory area in the brainstem, and you're good to go when we're discussing the origins of gamma motor. Okay. This is important. This is physiology. This bulboreticular area, peculiarly but relevantly, is mainly concerned, seems to be concerned with anti-gravity muscles and their contractions. Okay. Uh, Mind you, anti-gravity muscles are also very high on muscle spindles. You just need to connect these two informations and you're good to go. So, bulboreticular area is anatomically connected with your gamma efferent neurons of the spinal cord. Point number one. Point number one. Number two, most of this area seems to be controlling or connected to the anti-gravity back and lower limb muscles, and those muscles are rich in muscle spindles. This is painting you a very fine and clear picture. Welcome back. So gamma motor is very important in walking and running movements, these bulk movements of the lower limbs. Okay. I'm not saying it's not important in other movements, but it's mainly important in these movements. Okay. With this dose of anatomy, we move on to safer shores functions.